Hello, everyone. Hello out there. Welcome to beautiful Palo Alto, California. Here on a nice, kind of balmy Thursday, March 17th, 2016. We're here with the Silicon Valley Health Institute, live streaming and live in the audience. And we have some wonderful speakers this evening. And first of all, just a little bit about Silicon Valley Health Institute. We're a nonprofit organization sustained by membership. Membership is a whopping $60 a year. There are 12 meetings a year. And so for members who want to support natural health information from a scientific basis, this is your place to be and to contribute to. Contributions are appreciated. And we are having today a world-renowned speaker, Dr. Alessio Fasano. Did I say you're correct? Alessio. Okay, that good enough. Okay. And many of you are familiar with Dr. Fasano from a lot of his papers and his work over the years. In 2000, he and his team discovered Zonulin and how it regulates the gastrointestinal permeability. And just introduction of Dr. Fasano. Dr. Fasano, MD, is a chair of the Pediatric Gastroenterology and Nutrition and chief of the Division of Pediatric Gastroenterology and Nutrition at Massachusetts General Hospital for Children. His visionary research, which established the rate of celiac disease at 1 in 133 people, led to the awareness of celiac disease as a growing public health problem in the United States. Dr. Fasano founded the Center for Celiac Research and Treatment in 1996, where he treats adults and children for gluten-related disorders. Dr. Fasano is also director of Mucosal Immunology and Biology Research Center at MGHfC, which again is the Massachusetts General Hospital for Children. As I mentioned, in 2000, he and his team discovered the protein zonulin, which helps regulation of the GI barrier. It was a new way of looking at the function of intestinal permeability at that time, and has been groundbreaking in the effort to understand the mechanisms of GI barrier integrity and autoimmunity. Current research is directed, it encompasses both basic science, focused on bacterial pathogenesis, the gut microbiome, and intestinal mucosal biology, as well as transitional science focused on interventional clinical trials in autoimmune and in inflammatory diseases with the ultimate goal of prevention. So with that, I want to introduce and give a warm welcome to Dr. Fasano.
Right with the microphone? Okay. Thank you so much, everybody, to have me here. I'd love to be in California. It's 80 degrees. We left Boston. That was a little bit colder. I think that we also had a little bit of, contribution to stop the drought, since when we came over here, you guys had quite a lot of rain, so that's good. And I was asked by Susan, that's been very kind, to invite me here to discuss a little bit about how nutrition can influence the composition of the gut microbiota, and what is the implication in autoimmune diseases and chronic inflammatory disease in general. There are issues that pretty much encompass all the stuff that goes wrong with humankind. Got stuck already. It doesn't work.
Click on the screen.
Oh, this way? Okay, great. Start with a very provocative slide. System biology always taught us that if you're born with specific genes that put you at risk for any kind of disease, autoimmunity by anything, is destiny. Sooner or later, you will come down with this. Well, what you're going to hear today, this has been a total revisitation of the matter, and actually, it looks like, sure, you have to have genetic predisposition to develop diseases, but if you do or do not, it's totally in our hands. So, in other words, it's the way that we live, our lifestyle, that eventually may put us in a trajectory to have these genes to become operating into the development of these diseases. And by the same token, if we have a specific lifestyle that will never make this to materialize, we can live long and happy lives. So everything really depends on us. And this revolutionary thinking stems from the appreciation that the recipe to develop these chronic inflammatory diseases, including autoimmune diseases, is much more complex than we imagined at the beginning. For many, many years, the dogma was you have the genetic predisposition, you are exposed to something in the environment, and that's the recipe to develop these diseases. Now, again, we start really to have a much deeper understanding how this disease materializes. For sure, these two elements, so genetic predisposition and the environment, got to be there. So you have to have this wealth of genes that puts you at risk to develop these diseases. And you have to have the exposure to an environmental trigger that, in general, will eventually, put you in a situation in which you are supposed to get rid of these supposedly enemies, but because of your genetic predisposition, rather than to get rid of the enemies, the immune system starts to attack your own body, and that's how you develop, this chronic disease, including autoimmunity. A third element that surfaced relatively recently, and you heard in the introduction, it's been alluded several times, is that as a common denominator, it seems like that this loss of barrier function, so in other words, this interface with the environment that in general protect us to prevent these two elements, genes that live within us and these factors that live outside our body to really physically interact. When you lose this barrier function, and specifically the gut, you will see in a moment why it's the most important interface with the environment, then you can definitely have this physical interface, and that can really translate in the potential onset of diseases. Most definitely the immune system is part of the entire picture, because the immune system really is doing something wrong and will eventually create the syndicate to develop diseases. And finally, you heard, and we're going to spend a fair amount of time discussing the gut microbiome as a key element that was totally unknown to us. It seems to be extremely, extremely important. Again, provide the other elements of the recipe are there to develop these conditions, these diseases. We'd like to spend a little bit of time talking about gut permeability and the leaky gut theory. There are a lot of fantasies, very few facts. And again, I would like to go through these few facts that we have right now that really are now the cornerstone of understanding how the gut barrier is really regulated. Some factual elements that you need to be aware. When I said that the gut barrier is the most important we have, is because it's the largest that we have. In an adult, each of us, roughly, we have a tube that is the GI tract that's 20 feet long. And it was conceptualized until the recent past as a tube covered by single layer cells, all sealed each other. like roughly, like a floor in which each tile will be a cell, and the ground, the cement, will seal everything. Now, this 20 feet long tube is not smooth, but is made by valleys and hills, what we call, again, duplication, plicate, and then the cells, when you zoom in even more, they are this villi, they are this finger-like protrusion. They help a lot to digest and absorb foodstuff and crypts. And then, bottom line, if you take this 20 feet long tube and you stretch on a floor, you cover a double tennis court. So something a little bit, of this size, 3,000 square feet. That's as much we have in interface with the environment. Now, we always perceive this that was engineered to maximize the capability to digest and absorb foodstuff. And we totally overlooked these other key functions. And again, if you compare this interface with others, the skin, this is 10 times more the interface with skin, 6 times more the airways, almost 20 times more the interface with the genitourinary tract. So this seems to be the port of entry, the potential port of entry. A lot of these enemies that, again, on a specific genetic background, can put can put us out of balance and develop these conditions. In the mid-70s, a Japanese group actually came with an unbelievable discovery. They said, guys, this space in between cells is not sealed with grout or cement. There are doors. They are almost always closed, but there are doors that they end up to call tight junctions, meaning that, there are moments in which these doors can be opened and let stuff to come through. This was the mid-70s. They start to really understand a little bit the machinery that made these doors. It's not that I pretend that you look at this, but this is just to simplify that from that moment and the following 10 years, the number of elements that make this tight junction grew exponentially. Now it looks like there are almost 50 components that make these doors. And there is a rule of biology. When there is redundancy, when there is complexity, that means that that system must be extremely important for key function of our body. And these space in between cells, these doors that can really be so complex, they are not an exception to this rule. This space is extremely important. Now we start to appreciate the importance of this space. What happened is that in face of this tremendous, increase in knowledge of the structure of these doors, there was one information that was missing. Where is the key? Who opens and closes these doors? This was not known for many, many years. And we, by serendipity, stumbled on this protein that you heard that is called zonulin, that still remains the only physiological modulator of this tight junction that we're aware of. Probably it's going to be many more, but so far it's the only one that we have been able to discover. And what this molecules does for living is exactly that. Under specific circumstances, and we're going to explain a couple of those, these doors will be open for a short period of time because we need to do that for very specific physiological purposes. But again, as typically happens, when physiology is pushed to the limit and you spell from normal to abnormal to pathology, some bad things can happen. So what exactly would be the problem if rather than have this tidally controlled function of these doors, we got this door stuck open for a long period of time? Well, we got an answer by first and foremost realize where are the stimuli that make zonulin to be released. And two most powerful stimuli that we've been able to find so far are the wrong composition of the microbiome, that we're going to spend a lot of time on, and gluten, this molecule that comes from grains that is very offensive for some people. They have problem with it, particularly people with celiac disease, with allergy, and now this other condition is called non-celiac gluten sensitivity. They both are capable to really trigger the release of zonulin. And again, I'm showing this cartoon simply to say, once zonulin is released, there is a very complicated machinery into the cell that is turned on. And the final destination is this space in between cells that you see here. There are indeed this door. They go from closed to open in a matter of 15, 20 minutes. It's very fast. And as soon as the stimulus is off, so fast they will get closed again. So if everything works all right, we want this tidally controlled opening and closing of these gates. And we use this for several physiological reasons. At the gastrointestinal level, this is the way that we sample stuff from the environment so that our immune system will learn what is around and will be trained to defend us in case that this invasion goes out of control. The other thing that is interesting, you can't see this, but anyhow, the discovered zonulin up here in 2000. In light blue are the number of papers published in that particular year. In the dark blue is the production from our lab. So the first 2-3 years, we were the only one to publish this. But now there is an explosion of, literature, particularly since a commercially available zonulin ELISA became available. In the past 2-3 years, our lab very little contributed to the literature, but now there are actually 99 papers that have been published. And interestingly enough, these are the list of disease in which zonulin has been associated to. We didn't see this coming, honestly. So we started the observation with celiac disease, and now this has been associated to inflammatory bowel disease, colitis, the brain tumors like glioma, HIV, MS, non-alcoholic fatty liver disease, so fatty liver, non-celiac gluten sensitivity, obesity, sepsis after surgery, psoriasis, type 1 and type 2 diabetes. Again, and the list goes on and on and on. This all to testify that this tightly controlled space in between cells is so important to keep us healthy. And when this goes out of control, because these are all conditions in which the production of zonulin is so upregulated, so large, that these doors that are supposed to open and close, they got open and they get stuck open and stuff comes all the time. It's like the levees are broken and now you have this flood of stuff coming in. And matter of fact, this list that it's zonulin now parallel the list of diseases that have been associated with loss of barrier function, the quote-unquote leaky gut. And again, this list is not even complete, but there is a tremendous number of diseases that have been associated with the problem. The other thing that is extremely interesting, that the gene encoding zonulin is sitting in this very teeny tiny chromosome, chromosome 16. Only 3% of the human genome is in there, but it's packed with genes that have been associated to 3 major diseases that affect humankind, namely autoimmune diseases, cancer, and disease of the nervous system, neurodegenerative disease. So genes that are associated with inflammatory bowel disease, lupus, type 1, RA, for example, are sitting on this chromosome. A lot of cancer genes like, breast cancer, lymphoma, prostate cancer, sitting here finally. In terms of disease of the nervous system, the Lou Gehrig disease, leukodystrophy, MS, autism genes are sitting on this chromosome. And as I told you, since the zonulin gene was cloned, and this was not long ago, zonulin was discovered in 2000, the gene was cloned in 2010 and published in 2011, and ever since, exactly the same 3 categories of conditions have been linked to zonulin gene overexpression, namely autoimmune disease, cancer, again, among cancers, the brain cancer, breast cancer, adenocarcinoma of the lung, ovarian cancer, pancreatic cancer, and then, disease in the nervous system like MS, schizophrenia, and so on and so forth. So it is interesting that, something that supposedly is in the gut actually have such an array of conditions and problems that it can really affect any tissue or body in your body, a tissue or system in your body. Matter of fact, this morning I was telling this this lecture that I was doing this morning in San Francisco, that one of the quotes in my book there that I like is the fact that really the gut is not like Las Vegas. What happened in the gut doesn't stay in the gut. There is so much that can go wrong far from the intestine when something is really screwing up the system. And this brings me to the concept that many of these conditions that you see here, particularly autoimmune disease nowadays, we're in the midst of an epidemics. Does everybody knows what the hygiene hypothesis is? No, okay. Most of you, though, okay, I will give you the very short spill, okay? You are all at the right age to remember that once upon a time there was something that was called backyard. Backyard? The backyard that you go to Wikipedia is not there. And the new generation, they have no freaking clue what you're talking about. That's the place where you go and play. Put your hands in the dirt, put your mouth, dirt, butt, dirt, mouth. That was the way that we were training our immune system really to biff it up and fight. We don't have that anymore. We have now the couch. We have the play station. And if the kids not sneeze, but try to sneeze, mom, dad, grandpa, grandma, and uncle, they just jump with sanitizer. You got no chance. This fellow has no chance. And that's where the hygiene hypothesis is all about. So in other words, it's a theory that said we have been doing so well in cleaning ourselves up and be healthy, not being infected, that we end up to pay a price for it. Where this theory comes from this observation that was put forward, almost a dozen years ago. And again, this was just simply to look at history of humankind. These individuals, tried to really review what was going on in terms of infection in the past 50 years. And they noted that since we've done a tremendous service of intervention to prevent infectious diseases that were killers, honestly, we have been doing so well that only in half a century, all these diseases, including rheumatic fever, Hep A, TB, measles, they all are coming down big time. These in the northern hemisphere, okay, so industrialized countries. And at the same exactly timeline, in an opposite reverse, tendency, we had these epidemics of autoimmune diseases. In the same latitudes, so northern hemispheres, we had these epidemics, MS, Crohn's, type 1 diabetes, asthma, and so on and so forth. So we got ourselves so clean that on one hand, we're not dying right away of infectious diseases, but on the other hand, we die very slowly of these autoimmune diseases. And this was happening, again, in industrialized countries, while in the southern hemispheres, that was not happening because they still had problem with infections and they didn't have these epidemics of autoimmune diseases. And that's how they end up with this theory of, the hygiene hypothesis. This hypothesis put under scrutiny recently when the hygiene of some of the southern hemisphere countries have been improving, particularly North Africa and South America. So they do not have that kind of epidemics of those transmittable diseases, and yet they don't see this autoimmune process really ramping. So there's something else that is more than just that we're too clean for our goods. And this autoimmune epidemics is staggering. For example, in only 15 years, we increased by almost 45%, more than 45%, the prevalence of diabetes. Not here or here, everywhere, everywhere, north, south, everywhere. And again, this trend is continuing, and the projection is that by the time that we reach 2025, more than a 250 million people will have diabetes, so an increase of 172%. This is scary. This is extremely scary. Even scarier, it's something that I've never seen in my professional life. Now, the timeline is not 50 years anymore. The timeline is 30 years, okay? This is what the autism epidemics is happening here. 1 in 5,000 in 1975. This is not 1 in 88 anymore. 1 in 68 in 2013 of autistic spectrum disorder. Only 30 years, we have really totally screwed up the entire story to the point that, again, considering that the ratio between male and female for autism is 4:1, the next generation, 1 out of 4 boys will be out of commission because of autism. And you cannot blame genetics here. The time is way too short. We're changing the environment so fast that we cannot adapt anymore. And again, it is scary that, again, will be gluten, will be casein, will be God knows what. There is something that is tremendously and powerfully changed the story. And the same is happening for other autoimmune diseases like celiac disease. That, again, is a disease in which we thought that we knew everything because we know the genetics. It's the only autoimmune disease for which we know the trigger is gluten. And yet, every 15 years, we see a doubling of celiac disease. What is going on here? What is really the driving force that is really fueling these epidemics now without any precedent, out of proportion? And again, for celiac disease, because it's one of a kind autoimmune disease, we really try to dig into this and try to have an answer. Are we eating differently? So do we eat more gluten? Is the quality of gluten different? Are we doing something to gluten that now is different than the one that our grandparents were eating? It's the breastfeeding practice that is driving this. So because now we have such a society that doesn't allow us to take good care of babies because we have to go to work the day after that we deliver, and we don't have this chance. It's the timing that we introduce gluten. It's the maturity of the gut, and so on and so forth. Well, it's very difficult really to pinpoint what's going on unless you do prospective studies. So in other words, you can go back and look at the literature and ask yourself, can I see if there is a correlation here? But that really doesn't give you the real value of what this stuff can really do in terms of fueling these epidemics. The only way is to take a number of kids at birth at risk of celiac disease and follow over time. And again, this is what was done. And this paper was published only last year in a very reputable journal, meaning that, again, they see the value of following almost 800 kids from birth for 10 years and ask the question, what we have done to fuel these epidemics? It's the quality of gluten, when we introduce, and so on and so forth. And I have to say, after 10 years of very, very hard work, because to do a paper like this, it's a nightmare. It was a disappointment. We still don't know what the heck we're doing. As a matter of fact, we have a lot of negative results. For example, we thought that introducing gluten, that famous window of opportunity between 4 and 7 months, as the American Academy of Pediatrics recommends, it did not help. Breastfeeding, that is tremendously important, did not protect. Early introduction, there was a theory if we give a little bit of gluten very early, like to vaccinate these kids, it did not help. Delayed introduction of gluten to a year of age, so that will give time to the immune system to mature better, it did not help. The only two things that really pin out to be important were the possibility that gastrointestinal infection in the first year of life seems to increase the risk, and genetics. There are some genes that we know that must be present for celiac disease, particularly this HLA gene. If you have 2 copies of these HLA genes, you increase by 35-fold the chance to develop, celiac disease. But that's as much as we learn. And the other thing that was confirmed, the epidemics continues. So in these 10 years, we see again this increase of number of cases, and we still don't know what's going on. So we went back to the drawing board, and we focus on this guy here, the gut microbiome. I'm assuming, and again, while some of you guys never heard the hygiene hypothesis, I will be shocked if you didn't hear about the microbiome. You will be out of touch nowadays. It's everywhere, everywhere. A lot of stuff are, not really clear to the general readership. But, again, just to make sure that we're on the same wavelength, we were totally unaware of this parallel civilization that live with us from birth to death. The vast majority of these microorganisms cannot be cultured as we have done classically when we deal with infectious diseases in the petri dishes. So 95% of these inhabitants are not visible to us because we don't have methodology to grow them. So meaning that we were aware only at the tip of the iceberg of the microorganisms that live with us. Now we know that they outnumber our own cells by 10 to 1. So we are made by 10 bacteria for each cell of our body. I know that it's disgusting as an idea, but that's the reality of the story. And not only that, but they outnumber the amount of genes by a factor 150. So for each gene that we have, the microbiome provides 150 genes. There are many, many species that inhabit our body. And again, we were able to cultivate just 5% of them. The other thing that I want to tell you, and I don't want to get in this technicality, but when you read the microbiome literature, sometimes it's not appreciated that there is a hierarchy and sophistication of what we can study right now. Because many people keep asking me, okay, now that we studied the microbiome, let's jump straight to the solution to the problem. Let's take probiotics. Hold on, hold on. Again, what you see here is the hierarchy of what we know in terms of the, the field of microbiome. And again, if you allow me, this is the universe, this is the Milky Way, this is the solar system, this is Earth, this is, the West Coast, this is California, this is Palo Alto, and this is the building where we are. And the vast majority of the literature is the Milky Way. And how you can eventually intervene when you don't have even an idea of what we're dealing with, it's clearly not where we're supposed to go if we want to really customize and correct if something is wrong in the microbiome. We're going to get there, but we're not there quite yet, because that's where the vast majority of sophistication we will have. Only when we got to the species, so the specific microorganism, there is too much or too little in the microbiome, then we can say, okay, we take him out, or we supply that particular microorganism that is missing. That's what we're going to be able to do in the future when we can study the species level on a routine basis. The only thing that we can do right now, looking at this, is to say, okay, you know what? The rule now seems to be that this microbiome with these 10,000 species has to be very diversified. It's like that you have a community with different neighbors in which you have the Latinos and the Polish and the Italians and the Irish and so on and so forth. If they are diversified, they balance each other and they will be in peace. But if one of the neighbors will take over, then that will be a problem, because they will take all the resources in the neighbor and it's not going to be peace anymore. So this is happening to this community as well. If they're not in balance, but one of the elements of the microbiota takes over, so in other words, that again, there is less diversity, they're more homogeneous. They have to have 10,000 species, there are only 50, because they've been able to hijack nutrients and they whopped up the others. Bad news, bad news. That as much as we know. And again, very little for now, because that doesn't inform us what to do about it, but definitely at least it's a start in terms of appreciation what means when something goes out of control. Again, I don't want to go on technicalities, but be aware that this establishing a microbiome is an extremely, extremely complicated plan. And it's not that, even it seems that they happen randomly, Mother Nature, for the 2.5 million years of our evolution, have been designed this to the minimal details. Something that seems to be random, because you start, with these early colonizers, there are certain bacteria, and then they leave, and there are others, and then there is this commotion. until everything quiets down. When you turn 1, it's a not casual, random establishment. It's extremely tightly designed by Mother Nature if everything goes the way it's supposed to be. And this, random, apparently random change of the microbiome, it really is learning who you are, what is the environment that you live in, and like takes 2 to tango, the host decide who should stay and who should go, and the microbiota will seek, what kind of host is it trying to establish itself into to make sure that they both live in peace. Because one thing is for sure, under normal circumstances, because this is a common, decision to live together, what we call symbiosis, the only way that you can make this working, that there are win-win situation, it's like in any kind of relationship. You have to give in a little bit. And the plan is that then you can live happily together. But if there is one is bossy and therefore is a winner or loser, that will not be a good thing. And that's what the first year is all about. And again, this game has been played at the same way for almost 2.5 million years. Not anymore now. Because now intervenes stuff that were not planned by evolution that is perturbing this kind of mutual agreement on how we want to live together. The other thing that I want to tell you, again, not to get into technicalities, but if you start to read the literature, be aware what you read. The microbiome is telling you simply who is there. So we'll tell you, okay, these are the 10,000 species, if you read the species level, or these are the 10 phyli, so it depends on the hierarchy. But it tells you who is in this neighborhood. That's it. Then there is another science that is a little bit more recent that tells us what kind of language do they speak. What kind of language are they capable to talk? So in other words, what kind of genes they have. Can they speak Russian? Can they speak English? Can they speak Spanish, Italian, Greek? That's what this science of the metagenomics is telling us. But the most important, where the money is what they're talking about. Which of the genes that they have are expressed, because that's the way that they communicate with us. And that's where now the science in the past year and a half is really focusing on. What kind of communication we receive from the microbiota and how this impinges on our state of health. I'm going to tell you what I told the folks today. If you were distracted till now because you were playing with your cell phone or you were get asleep, that will be fine. But I need 2 minutes right here because this is the most important slide that I have to show you. After which you can go back and play with your, cell phone. So this is a theory that we put forward 5 or 6 years ago that now start to really get momentum. If you're lucky, you are on the left side of this slide. You were born the way the Mother Nature decided that we have to be born, by vaginal delivery. You've been fed food, not what we feed right now to our kids, real food, okay? Stuff that you know what is made of in the plate. Very little or no infections, no antibiotic treatments. All this will maintain the microbiota composition in good balance. A balanced microbiota, the ones that I was telling you, not bossy, but diversified, is extremely important, particularly in the first 3 years of life, because among the many things that the microbiota does, the key function is to train our immune system to fight if and when and how to deploy this weaponry. When it was engineered by evolution, the immune system was built to fight only one enemy, only one, infections. Our ancestor would die either by infection or a predator will eat them. It's only the past few hundred years that the immune system has to fight many enemies that did not exist during the evolution, including pollution, radiations, chemical, cancers, this stuff the immune system never fought. And because of that, we should not be surprised that who train the immune system to work properly are the targets. And the balanced microbiome will teach the immune system, listen, you need to unleash weapons only when you are under a tremendous danger. Why? Because you need this bar of inflammation very high. What's going to happen with this inflammation? That you will create an environment that's extremely unfriendly for microorganisms to grow. It's too hot. There are chemicals that will destroy bacteria. In other words, this is not good for the bacteria to grow. And therefore, you stop infection, but you pay a price because inflammation will destroy the tissue where this inflammation occurred. But the return on investment is that you save the big picture. So in other words, the entire organism will leave, even if the tissue will die. Once again, you want this bar extremely high. Now, let's go on the right-hand side of the slide. You're out of luck. You're born by C-section. You've been fed what we feed our kids nowadays. Then again, we don't know what is in there because we don't cook. Somebody else does, and God knows what they put in there. We got multiple infections, a lot of antibiotics. Bottom line, we put this microbiome in imbalance, what we call dysbiosis. Now what happened? That an imbalanced microbiota will teach the immune system to unleash inflammation even when it's not needed. So the bar is so low that during our lifetime, we will unleash this inflammation over and over and over again. And it's just a question of time that if you're genetically predisposed, that inflammation will lead to disease. I don't mean just autoimmune disease. I mean Alzheimer. I mean breast cancer. I mean, chronic inflammatory diseases that we are affected one way or another, including people that now believe that lifetime span, so in other words, how we age, is influenced by this. Now, I hope that I communicate with you that the equation here is made by something that you do not control. That is your genetics, and something that you definitely control. That is your lifestyle. You can go back asleep. Why I put so much emphasis on this? Because again, Mother Nature is teaching us that this microbiome is extremely, extremely important. We know that breast milk is the best that we can give to the babies. We know this as a fact. Few people, they know that actually, if you just look at the composition of the breast milk and you see that HMO, human monogo oligosaccharides, these are sugars. There are tons of them in the breast milk. They are totally, totally useless to feed babies. Babies cannot use those sugars. Why we spend so much energy to put the sugars in the milk if they cannot be used by our babies? The only thing that these sugars they do, they feed the microbiome. That's the only thing that they do. And if you feed the microbiome with these sugars, you got the good bacteria there, the one that we definitely need to keep that level of peace so that, again, we do not disturb our genetics that will put us over the edge. And we know that, again, this intestinal flora, the microbiome, really influence, again, how we mature as an individual, particularly how the immune system matures the way that I just told you. What has happened when this goes out of control? So in other words, when we go off balance, there are two major conditions now that we're aware. The change in composition versus the change in distribution. So in other words, what's going to happen if you have a dysbiosis versus if you have microorganisms that rather to sit and live where we want them to sit, colon, very last part of the intestine, no food anymore. We ate everything. The leftover that we cannot use, like fibers we got there, we like that because we feed them and then in exchange give us good stuff that we need. What happens if these folks, they move from there and come all the way up where we have a plenty of nutrients? That would be bad news, and you'll see in a moment. So, again, there have been plenty of data in the literature between a correlation, and I want to underline this word. Remember, I'm talking about correlation between imbalanced microbiota and human diseases. The obvious are conditions that affect the GI tract, like inflammatory bowel diseases, colon cancer. We will expect that because, again, everything happened in the battlefield. What we didn't expect, again, goes back to the concept that the gut is not like Las Vegas, that an imbalanced microbiota can have repercussion on heart disease, liver disease, brain conditions that can be either, neurodegeneration of behavior, prostate cancer, kidney infections, lung in terms of allergy infections, and, the pancreas with diabetes and so on and so forth. So the gut microbiota has been correlated, this imbalance, this biosis, to a plethora of conditions that are chronic inflammatory diseases that affect humankind. And again, this is the most obvious stuff that we've been seeing. For example, the correlation between, food allergies and the microbiota that goes one way. If you develop allergies, it goes the opposite way, does not. And again, these are correlation. So we look at the number of kids with allergic diseases. We look at the number of kids that do not have allergic diseases. We study the microbiota both. We see these differences, and then we say, oh, you know what? These guys, bacteroidetes, they go up if you have allergies compared to the one that don't have, and the contrary up to the other one. Just correlation. We did the same. We did the study with celiac disease. We saw the same kind of situation, that kids with celiac disease predisposition as an imbalanced microbiome compared to the kids that did not have, celiac disease. So simply correlation. But correlation is not causation. It does not imply causation. So the fact that two things correlate, that means that one really leads to the other. Because if we believe that every single time there is correlation imply causation, then we have to believe that the more chocolate we eat, the more chance we have to win a Nobel Prize. There is a strong correlation, the amount of chocolate we eat and the chance to leave a Nobel Prize. So there is a lot of Nobel Prize in Switzerland because they eat a lot of chocolate. And there is no such a thing. I try to eat a lot of chocolate. Nobel Prize is not coming. By the same token, if you believe that that's the case, this is a correlation between the amount of fresh lemons they import from Mexico and the total U.S. airways fatality rates. So in other words, there is an inverse correlation. The more lemons you bring in, the less fatality on a highway. Of course. And the correlation is huge. It's almost perfect. But we know that there's no such a thing. So all this to say, again, correlation does not imply causation. There is a way to do that. And that's how we now start to move from correlation to causation. It takes, and again, I don't want to go into these details, but it takes steps to play with the toy. And now we start just understanding how to do it. So if somebody will come to you and say, oh, we can study the microbiota, tell you exactly what to take, it's not really give you the factual situation where we are. We will get there. We will. But we're just moving the first steps in that direction. So I think that, again, it will be a little bit presumptuous to say, okay, now we know everything. We know how to treat, a certain condition with a certain prebiotics, probiotics, symbiotics. No, we do not. We're learning. And again, we will get there. But again, I don't think that we're quite there yet. And we have made some strives to move from association to causation. For example, we were able, in these folks that I was telling you, at risk of celiac disease, to find some metabolites that were increased before they onset the disease. And now we're trying to figure out, can we predict, for example, based on the fact that these folks that eventually, months later, had this specific metabolite that was peaking, if this indeed is the red flag, that every single time that I see these metabolites go up, it's a matter of time that these folks genetically at risk for celiac disease will develop the disease. Again, we're not quite there yet. We have now a system that we're trying, in other words, really to make this move from association to causation. What is the point that I want to bring home, bottom line? That again, we wrote the textbook of history. And therefore, we took the freedom to say that we're the most complex beings on the face of earth. Lie. It's a deep lie. It's not true. And we don't know a lot about ourselves. When we had the presumptuous approach to make ourselves gods by saying we will develop a best way to stop diseases forever by studying the human genome, God, the nature, whatever you want to call, was laughing so hard. Because by the time that we finished this project, we realized that genetically speaking, we are the most rudimental being on the face of Earth. And when I say the most, I say by far the most. We were not supposed to sit here and have this intelligible discussion. Other beings were supposed to be here. I don't know if we're dinosaurs, ants, or flies, whatever, but we definitely, with only 25,000 genes, we're at the very bottom of the hierarchy of sophistication. Anybody is a fisherman here, fisherwoman? Anybody goes fishing? No. Oh, here we go. Okay. The worm that you use to go fishing, 75,000 genes, 3 times more the worm that you have. So next time that you put the worm on the hook, think about it. The plant that makes gluten, wheat, 150,000 genes. We're made by only 25,000 genes. Only 400 genes makes us different from chimpanzees. I work with chimpanzees. Can talk about poetry with chimpanzees. Definitely, I was telling this morning, can't talk how distressed I'm about the American politics with chimpanzees. They do not respond. They seem to do not care what's going on here. And yet, we're almost identical. Almost identical. How is possible that we are so different? And again, the most remarkable difference that makes us unique is the capability to attach and lose attachment. That's what makes us humans. The memory of binding and bonding and the loss of it. And this is something that definitely has some genetic makeup that makes us unique. But also, it will require a parallel civilization that complexly will provide us 150 times more genes than we do. So truly, if you want to understand who you are, you need to think that you're made by 2 genomes. The human genome, the one that you inherited from your mother and father, the one that if you are out of luck, that will put you at risk for prostate cancers, breast cancer, Alzheimer, autoimmune diseases, and so on and so forth, is there, but doesn't mean that that's destiny that you will reach that final destination. If you do or do not, depends on the other guy on the right there, the microbiome. That changes all the time. It changes from one individual to another, and in the same individual over time. And it's highly, highly influenced by lifestyle. Highly. Everything that I told you, the way that you eat, the infections, the antibiotics, abuse, exposure to chemicals, exposure to radiation, guess what? They all come down in impinging how the microbiome is composed. That's the bottleneck. And these are the guys that talk with us through these genes for what we call epigenetics, so the capability to modify our genes if and when expressed, because they talk with us. It's not the chemical that does this. Rarely we have example of the chemical that directly can change genes or a radiation. Under specific circumstances it can happen, but it's most frequently through the change in the composition of the microbiome. So the way that and again, if you're lucky, you got your microbiome from your mother. Why? Because she has been able to select a microbiome that live in peace with her genes and most likely will live in peace with our gene. And if we're not lucky, we're born by C-section, the chance that you're in trouble is much, much higher. If you're born by C-section, the chance to develop type 1 diabetes or celiac disease is 5 times more. Why? Because if you look at the microbiome composition, this is the microbiome in the mouth of the mother as a control. If you're born by vaginal delivery, the pink dots here, your microbiome is very similar to the microbiome and the vaginal and intestinal canal of the mother. And that is not there by chance. It's been selected. It's been selected. And the other thing is, if you're born by C-section, light blue, your microbiome is very similar to the microbiome on the skin of the mother, all comers. So there have been good guys and bad guys. Mom didn't select that microbiome. And there's one more thing that we didn't know until the recent past. We thought that we were sterile in the wounds. We're not. The microbiome starts to colonize the intestine while we are still in the womb of mom. How did that happen? Because the last trimester, that's the reason why it's important also to be born at term and not preemie, and by vaginal delivery, no C-section. During the last semester, some very specialized immune cells of the mother that we call dendritic cells, they got into the gut, they put out periscopes, they sampled the good bacteria, they take it, they put inside their own cell, and through the bloodstream and the placenta will deliver that to the baby so that the microbiome start to colonize the baby during the last trimester. So also, this would tell us how important is this parallel civilization that lives with us from birth to death. So the way that I try to explain everything that I told you to my students is consider the human genome as a piano with 25,000 notes, one for each gene. And let's say that to play the song breast cancer, celiac disease, Alzheimer, you need to touch 300 of these notes. You need a piano player. And the piano player turns to be the microbiome. The human genome doesn't change. You don't trade in. That's done. This is a very expensive piano. You don't trade in. These notes, they are, defective, are there. But it doesn't mean that necessarily you're going to use them. It depends who played the piano. If you have Elton John that is playing pop music and touch 2 of the 300 notes, you don't play the song chronic inflammatory diseases, meaning cancer, autoimmune disease, food allergy. You don't. But if you have a wrong lifestyle and you have this piano player that goes out of control, and now you have a virtuoso like Chopin, he may be able to touch all 300 notes. And that's the perfect storm to develop these diseases. And again, this is totally dictated by lifestyle. Radiation, infections, the way that you're born, exposure to chemicals are all occasional events. By far, the events that are most influential on the microbiome composition is what we do 3-4 times a day, eating. What we eat is what we feed to these folks. We eat junk, they will be belligerent. I can make mice extremely, extremely sick by feeding McDonald's every day. If I do give red meat every day, this mice will have tremendous inflammation in a matter of 7 weeks. This is not interpretation, this is factual. And again, I'm not against McDonald's. I'm telling you the way it is, okay? And again, we know by looking at this metabolic profile, the kind of song they're playing, and therefore we may in the future predict who is gonna get in trouble just looking at what kind of metabolites there. If I hear pop music, so a certain metabolic profile, I can extrapolate that the good guy is sitting there. As soon as I start to hear classic music, I know that the bad guy is sitting there. It's a matter of time that on that specific genetic background, I would get in trouble. And we have been entrusted by the NIH to do exactly that with this project that's called Celiac Disease Genomic Environmental Microbiome Metabolomic Study, or CDGEM for short. What is the purpose of this? We want to go ahead with what's going to be the future, the prediction of the disease, because the microbiome and all these multi-omic studies will do 2 things. What President Obama calls precision medicine or personalized medicine, so that we know exactly how to treat the same disease in different people, because there is no such a thing, a magic pill that can really fix that disease the same for everybody. And most importantly, we care about prevention medicine. we do a disservice to ourselves in terms of health care because we do much better for our cars than ourselves. We go to Jeff Filube, change the oil, even the car is running. Because we know that if we don't do that, changing the engine will be much more expensive. But with health, we go to the doctor when we have something broken. And it's not cost effective. It's not sustainable over time, by the way, because we'll go bankrupt if we continue to do healthcare the way that we do right now. And what is amazing is the fixing of this is not the expensive pill. It's lifestyle. Something that we can definitely implement. Something that has been changing dramatically only in 3 generations. In 2.5 years of evolution, we've been having the same lifestyle that tremendously changed only in the past 3 generations. So the tape can be rewound so that we can stop these epidemics. And I'm going to finish up with, well, actually, you know what? I want to stop right now so we can have question and answer here. But I want to finish up by saying, you know, really, I hope that I passed to you the message that, again, our destiny is totally in our hands. The way that we make excuse that the story has to go the way it goes has no justification. Myself and my beloved one here, we work extremely hard. We go home 8 o'clock. We cook from scratch. It takes 20 minutes. It's an excuse that we don't have the time to cook anymore. I don't clean. She cleans because I don't like it. That's time consuming. But, you know, well, sometimes I clean. So anyhow, but that's an excuse. And of course, I'm not saying that we have to go back to the caveman lifestyle. That's not the purpose of what I'm trying to communicate. I would not, you know, I was telling this morning, of course we know that, you know, the cell phone are going to give us brain tumors if we misuse them. But nobody will be so insane to say, okay, we're not going to use cell phone anymore. There is a logical way to use it. Communicate, few minutes, hang up, rather than be 2 hours on the cell phone. We know that cars pollutes. Best use, not to just take a ride and you know, just to go 3 blocks to go food shopping. No, you walk there. You take the car when it's needed, and use wisely in terms of the kind of fuel that you use. Same in terms of lifestyle, including nutrition. You know, we need to be wise. We have been evolving as a species for many, many millennia by eating fruits, vegetables, fresh meat, lean, fresh fish, tubers, nuts. In other words, the Mediterranean diet. The more we diverge with that, the more we'll be in trouble. Meaning we don't use McDonald's anymore, maybe once in a while, but not every freaking day. Because that will definitely put us in major trouble. And once again, I believe that the kind of message that Mother Nature is passing along to us is that we create the problem, we got to fix the problem. Nobody else but us, with a little bit of common sense, you know, should fix the problem. And I know that you Californians, you are ahead of the game of the others because you're so fixated about all this that you should not really be too much in trouble in really embracing a healthy lifestyle. Thank you so much.
Thank you. Hello. Can you hear me?
Yep.
Okay. All right. Okay. Thank you so much, Dr. Fasano. And we're going to take, do you want to take questions till 8:30?
Fine. Yep.
Okay. All right. And I'm going to come around and give the microphone to you so that we can get it for the audience watching in also. So please wait, raise your hand, and I will come to you.
Currently, we sample the microbiome fecally because of accessibility issues and all of that. And do you have any techniques or any ideas about techniques for how, in looking at that particular sample, to infer the dynamics of what's going on upstream, where certain bacteria that may not show up downstream might still be present upstream, but may be eaten by or preyed upon by bacteriophages or bacterial competition or bacterial fungal competition. Do you have any kind of way of inferring that kind of upstream dynamics at this point in time?
Of course, in trying to communicate in a relatively short period of time, I simplify a matter that is much more complex. And matter of fact, there is also the question is, how valuable is the microbiome that's been shed off? In other words, that they've been not welcomed anymore, and therefore it's in your stools, compared to the one that sit there, is communicating because it's in the mucosa. And how important is to sample this throughout the GI tract. Not only that, but the microbiome is only part of the story. There is the virome, i.e. the viruses that live with us, that when they enter into the microorganism, they change their behavior, and therefore the gene expression, and that complicates the story even more, and the parasitome, and so on and so forth. So anyhow, long story short, ideally we should sample what is on the mucosa. This is not technically feasible, because if you do, and assuming that you will go with this invasive procedure to an endoscopy, a colonoscopy, you cover 10% of these 20 feet. The rest is not visible to us because it's not reachable by the scope. However, when I was in Maryland, there is an institute that's called the Institute of Genome Science that was heavily involved in the human microbiome project, and we've been doing some of this in chimpanzees again. And so we've been sampling throughout the GI tract to see how much, this different, and how much different from what you have in the stools. The simple answer is there is difference, for sure, but not that substantial to not use the fecal microbiome as a good proxy of what's going on in the mucosa. So in other words, you don't see this tremendously different distribution of the species of the villi in the stools compared to one they are in the mucosa. They are pretty much the same. What it changes, again, the balance, the abundance of each of them. That's the reason why also, put so much emphasis on the abundance. It's a little bit deceptive. All this to say, the best that we can do is really what is practical. So collect stools, and be mindful that this is not identical to what's going on the battlefield, but pretty much a good reflection of what you would expect there.
What is your opinion or suggestion with respect to vitamins and probiotics?
All right, I will start with probiotics. I believe that they hold a tremendously powerful promises. I'm afraid that, and again, we discussed this morning as well, we're making with probiotics the same mistakes that we made with antibiotics when penicillin was discovered. This was the time in which we thought that the penicillin would fight all the infections, and see what kind of disaster we created by promiscuously use that. We know now that penicillin works only on gram-positive and not gram-negative. We know that the frequent use create monsters, i.e., gram-positive microorganisms now are resistant. And mainly because we did this without knowing exactly what we're dealing with. And that was infections. Now we talk about something much more complex. So I really do believe that probiotics have a tremendous important role if we use them wisely. So I think that we should not rush into the promiscuous use of probiotics. We should learn a little bit more what is the composition. We should go down to the species level again and then customize. We will get there. The way that I see the future, in other words, is that you come to the office, your next generation physician, with your genomic chip that goes in the computer, so he or she knows who you are genetically speaking, and you bring your stool samples that will go in the back, that will be analyzed. By the time that the visit is finished, he or she will put this together, and this very complex algorithm will say, oh, you know what? Right now, you have a condition that in 20 years, you have a 50-fold increased chance to develop colon cancer. And you should take these probiotics to ameliorate that. That's what I see coming in the future, not now. Oh, the vitamins, I'm sorry. Vitamins, we know now that are not just cofactors, I would believe before, in terms of helping some enzymes to work properly, but they have a tremendous impact on many functions, particularly the immune function, see vitamin D, for example, and what it does, to prevent autoimmunity and so on and so forth, on behavior and so on. And now we start to really see that vitamins may have an effect also on the microbiota composition. There, I see less of a problem. However, I believe that the best way to supply, your body with the right proportion and balance of vitamins is, once again, if at all possible, natural sources. And I'm telling you this because, again, this has been engineered for 2.5 million years, and it's been engineered to have in the tank a specific kind of fuel. It's only in the past 200 years that we changed the kind of fuel that we want to put in there. And that's the reason why the engine is not really performing the way that we're supposed to. I was, again, telling this morning, it's mesmerizing, realize that the refrigerator was invented only 3 generations ago. There was no such a thing. Most of us, I believe, were born before the microwave was invented. You talk with my daughter, that she's 25, and she thinks that this is the way that you cook. That's what is cooking. Put something in the microwave and push a button. And again, for us, it's happened under our, watch eyes in the past, 2-3 generations.
Antibiotics, I think I've heard wipe out, a huge amount of the microbiome. And you've just talked about these lovely little things that go get the mom's microbiome and bring them in. We don't have that as an alternative as an adult, so it sounds like we're kind of like in deep trouble, in fact, once we've taken antibiotics.
I don't want to leave you with the impression that, antibiotics are, bad, period, because, it's been one of the most revolutionary events in science. The problem is the way that we made use of. I mean, again, by all means, if you have a pneumonia or a meningitis, you got to take antibiotics, otherwise, you will be in deep doo-doo, and that's fine. But what I have a problem with is when we have particularly young folks, 2-3 years old, with these recurrent, fevers that 95% are viral, and we give antibiotics to these folks, either because we believe that, maybe there is a bacterial component, or because you want to cover them for a possible superinfection with microorganisms. The disservice that we do is tremendous because, it's been proved in humans that one cycle of antibiotics will change the microbiota composition. To go back will take months, not weeks, months. Sometimes they don't go back at all. Some people, they claim, again, association, non-causation. So don't get me wrong here, that when you develop a situation like chronic fatigue syndrome, fibromyalgia, or IBS, it's the consequence that you change the microbiome through a cycle of antibiotics, and now you cannot fix that anymore because it's not taking weeks or months. It's not coming back anymore. Again, what I'm saying is, if necessary, you got to do it. But if it's not necessary, I will definitely avoid it. And if you have to do it, be mindful. What else you can do? I don't see anything wrong, for example, to use natural source of probiotics, like yogurt, a good Greek yogurt, if you have to take, antibiotics. Why I'm not saying the probiotics on the market? Because again, this is so confused now in terms of lack of regulation. We don't know what is in there. People, they take a look and say, the CF foods, so in other words, the amount of colonies is so low that definitely they will not do anything. Some other people say that there is no probiotic at all in there. Some people, they even found pathogen bacteria in there. So until we have a regulation, and again, we understand how to use that, I think that the natural source is the best way to go.
Hi, great lecture. I wanted to ask you, could you please speak to prebiotics generally, and could you also speak to them in terms of training the body to work better for itself in a way that works better?
That's right. So prebiotics indeed are the resources, the food with which we, feed, microorganisms. And again, the best prebiotics come from fruits and vegetables. So if at all possible, I think that, again, this would be the best way to do it. So that, again, it's like that you have your own, farm with your own animals. You wake up in the morning and you feed them, and you feed different things because, pigs, they eat stuff different from cows, different from chickens, and so on and so forth. And the same applies with prebiotics. That would be the ideal approach. And again, not because I'm from Europe and specifically from Italy, but the Mediterranean diet is the best way to provide the right prebiotics. Lifestyle. Again, we're not apt, for example, to sit 8 hours. That, the column, the skeleton is being built to do something different, and again, we unfortunately are forced sometimes to sit for a long time because the job that we're doing and so on and so forth. We don't walk as much as we used to. We give for granted that, what we're doing is the way that we should live. Well, again, I keep telling myself the best way, really, in terms of lifestyle, is to ask yourself, did my grandmother did that? If you do that, and again, we're talking about 2 generations ago, I believe that you will have the answer to your question, what should I do to stay healthy, to maximize my potential as a human being? And that's the best word of wisdom that I can give you. I know that it's not really an intelligible answer, but I believe that right now it's the best way that I can answer, your question.
I work with a lot of people with SIBO, and I know you didn't have time to cover it, but could you just say a few things about
Sure.
SIBO and small intestinal bacterial
Overgrowth. Okay. So again, SIBO is a condition in which, again, you have microorganisms. They are in a small, intestine, and they are not supposed to be there, and therefore this will create a situation in which they ferment. And with the fermentation, they produce gas, and with gas, they produce eventually GI symptoms that typically characterize these individuals. But also, they produce a situation in which you have a breach of the barrier. As I told you, one of the stimuli to release zonulin is the imbalance in microbiome. And when the microbiome is in the small intestine, you can release zonulin that opens this junction. Junk, particularly endotoxin, can come through. And when they come through, they can create this chronic state of inflammation that can lead really to problems. And again, there are people that believe that SIBO can be associated to fibromyalgia and so on and so forth. And again, now that we are a little bit more liberal, not a clinic, to do breath antigen tests for SIBO, we start to see a critical mass of individuals that have that. That's, again, it's a work in progress, and I believe that, there is clearly the rationale that at least in the specific conditions, you need to really think of possibility of SIBO and then to treat it. The problem is, what do you use for that? And that's very, very challenging. What you see out there is to use antibiotics. Once again, this could be one of the conditions which you should do that. Be mindful, though, that while you fix the problem up, then you create the problem down. And, there is a tremendous amount of effort to try to find different ways to treat SIBO other than antibiotics.
Hi, I have a question. I have 2 questions. Do you, when you're washing your fruits and vegetables, do you leave some of the dirt on?
I did my job when I was a young kid. I played in my backyard, so I got my dirt all right. Okay. So I clean now.
Okay, and I have one other question. What do you think of GMOs on the gut microbiome? What do you see as a potential?
I was waiting for
We're
this
in California, so.
And again, I will answer to you as I answered the fellow that asked the question this morning. Genetic modified, food seems to be a big deal. So much so that the American Academy of Science, the highest, authority in science in the United States, organized almost a year ago a meeting to answer the question, are we really putting ourselves out of business with these GMOs? And the answer was, Not necessarily so. Not because GMOs are not bad for you, probably they are, but there are not that many as we anticipated. For example, there is no genetic engineered wheat. There is genetic engineered maize, but not wheat. And I really do believe that they can definitely impinge on the microbiome. But be mindful, for example, that in Europe, GMOs are not allowed, and they see the same epidemics that we see. I believe that the pesticides on some of this stuff can do much more harm than the GMOs. I'm not trying to defend, genetically engineered, food, but for example, personally, if you tell me that you genetically engineer a crop so they cannot be attached by parasites and use that crop in the developing countries where something like this means 30% of mortality, I'm all for it. Provided that, again, I know that, the price that I'm going to pay is bearable. It's like use antibiotics when it's needed. Because, here I would not do that because we have other means and to diversify the business. But, again, I think that, again, why GMOs may definitely have a negative impact on the microbiome. There are many more things that they have such an impact.
So any thoughts on sauerkraut or other fermented foods?
Well, again, some people believe that fermented food may have that prebiotics effect that help the microbiota to be, fed the right way. I personally believe that, I'm not pro or against. One thing that I will not compromise is to eat stuff that really is disgusting to me. So if that is not, by all means, that can be done. But boy, life is way too short to eat fermented stuff that just smells bad. If it's not, by all means. By the way, I went, there was a fellow, once we gave a lecture at this meeting, he was giving a lecture, after that I was giving one, and he was a firm believer of the paleo diet. So we had this lunch break, and there was some salad available, and he brought his own stuff that consisted in 2 pounds of ground beef uncooked that he was eating with a fork in front of me. I mean, clearly he was disgusted. But the point that he was trying to make, that he had to eat that way because, that's how we evolved as a species. And therefore, he wants to definitely do that. But I can tell you, particularly when he got to the oxidated parts, so the brown, he was ready to vomit. I did. Poke on the table there. So.
Thank you so much, first of all, for your work in this field. It's so exciting and empowering to know that we have so much more control over our health outcomes than we ever thought possible, and especially with the leaky gut, which I didn't hear you talk too much about. I'm curious, it sounds now that there are several preconditions. You have to have the genes, plus the toxic threshold. Is a leaky gut mandatory for autoimmune conditions and a dysbiosis? Or is it not 100% correlation?
So, again, I'm giving you a very biased answer here. So be mindful. I really do believe, again, I don't know a lot of things, but a few things that I know is gut physiology. I've been studying this for way too long. And one thing that immunologists never been able to understand is how molecule that needs to be big in order to be seen by the immune system will gut in our body so that you trigger conditions that leads to immune-mediated diseases, including autoimmune diseases. And they always brush this off. It's happening, and that's enough. But again, if you are a gut physiologist, you will clearly not be satisfied about this answer because big molecules will never, ever make the journey. It's like to pretend that I close the door and I walk out of this without opening it. That would be frightening. You got to open it to get out of there. And that's how this leaky gut story starts to take momentum. Why there is no general agreement? One, because again, we didn't know of the existence. We didn't know how this was done and regulated, because alternative and complementary medicine that was visionary in that abused the term, and therefore this has been vilified by creating the syndicate that, again, this is the explanation, everything goes wrong in life and so on and so forth. But now I believe that slowly but surely there is a general agreement that, this loss of barrier function is an integral part of the story. And matter of fact, I didn't have the time to go in details, and I apologize, but, I'm so passionate, I can give another lecture. We'll be here until tomorrow morning. This has been our, way of scientific life for the past 25 years. Now that the recipe that I show you implies genes, environment, loss of barrier function, immune system, and so on and so forth, implies any of the 5 components that you subtract, you can stop the final destination. I don't know if you appreciate what I just said. Classical immunologists will say you develop autoimmunity, done deal. You can't do anything about this. And we'll say, wait a second. I cannot believe that we engineered an immune system to defend us, not to attack us, and was built to be turned on when it's under attack and to turn off when we are not under attack. And yet we have situations like autoimmune diseases in which it's on and you cannot turn off. Evolution will have eliminated these people. And we said, we really believe that this is happening because the immune system continues to be bombarded by these instigators. Example, celiac disease. Put these people on a gluten-free diet. The enemy is not there anymore. The autoimmune process shuts down completely. And that has to be the same for these autoimmune diseases. Why we can do that? Because we don't know the environmental trigger. If we knew, like celiac disease, we'll be able to treat that. But if you cannot take the enemy that is creating the problem out, but you stop the leaky gut, can you achieve the same goal? And the answer is yes. This inhibitor Zonulin is in the phase 3 trial right now. So you can continue eating gluten, for example, and you're not get sick. Animals that are predisposed to type 1 diabetes and they are exposed to this Zonulin inhibitor, 80% of them, they don't develop diabetes anymore. And as soon as this inhibitor will become commercially available, hopefully, and will be used for other autoimmune diseases, this will be a total shift of paradigm. Total. Once again, use the inhibitor Zonulin or change the microbiota so Zonulin is not produced anymore, will be the same thing.
Dr. Fasano, I want to ask a question regarding that. As a clinician, I've been practicing functional medicine essentially for 26 years, and I've seen more so recently people who I've run the various Cyrex tests on where I'm checking markers for gut permeability, and I've found some people without gut permeability on using those markers who, however, have autoimmune disorders, but they are high with heavy metals or mycotoxins. Therefore, I've seen that you can have that without increased hyperpermeability, though rarely, that you can have situations such as that where you do have induction of autoimmunity.
Yeah, again, biology is beautiful because there is no absolutes. So every rule has exception, and gut permeability at these conditions apply to that as well. Said that, a couple things that needs to be considered. Some of the tests for gut permeability are not completely validated, so we have to be careful. We don't have a perfect, test yet. And 2, this is extremely dynamic. It's not that you leak all the time. This is cyclical. So sometimes you do the tests in which in that particular moment you don't have a detectable, increased permeability, and maybe that you do this 3 hours later under different conditions, for example, postprandial, and that changed completely. So, there is such a thing. Said that though, I will be totally okay if there are some cases in which you have a situation in which you don't have increased permeability, yet you have a chronic inflammatory condition ongoing.
Just a quick question about celiac. Can it be reversed? I mean, if you get your gut back in balance, can you go back to eating gluten, or is that?
No, dear. There is no such a thing. There is an attempt to do that with a vaccine. So there is a colleague from Australia that now has a company that is based in Boston that is trying to do exactly that. So in other words, to re-educate the immune system to say, okay, don't get work up if you're exposed to gluten. Just stay put. And if you really get the immune system, at least on paper, there is a possibility to go back to eat gluten. But as we are right now, this is the culprit why the immune system starts to attack your own body. And the only solution that we have is either the gluten-free diet or any other remedy that will come in the pipeline that prevent gluten to come through.
Is it appropriate to think about stress and emotion in relation to the opening of the gateway?
All right, so here we take not one, but two, lectures here. I have to say that again, stress is the most powerful stimulus to put us in a situation, an imbalance of the microbiome, loss of barrier function, and so on and so forth. So, and again, this is factual. And a matter of fact, some people that really are able to control some of this key function just with meditation, with prayer, Tai Chi, acupuncture, you name it. Even the most skeptical individual that are totally evidence-based will tell you that the strongest stimulus to boost your immune system are not medications, are not any other remedy that's there. Laughing. If you have a good laugh, that will really boost your immune system. Meaning the contrary, somebody that is depressed, is stressed out, will definitely have an immune system that is going to work in an inappropriate way. And many other, and we know when you're stressed, the gut motility is affected, and the gut motility affects the composition of the microbiota. So definitely, that there is a correlation there as well. But this is way too fascinating. We'll take, again, another entire 2 hours of discussion. Last question I will give to Susan. So, and then, yep. Oh, last two
What
questions.
do you do when your doctor insists you take antacids for 6 months?
Okay. Well, how can I put this in a polite way? There are moments in which you need the antibiotics because you are infection. There are moments that you have to take the antacid because otherwise that will really have a negative impact for you. But you cannot live on antacids. We tried that, and we know now that there are severe consequences to chronically, depress the acidity of your stomach, including the composition of microbiota. I'm sorry to be repetitive here, because one of the ways that we really protect ourselves for this wealth of microorganisms we ingest on a daily basis is to create a very harsh environment with a pH 2, very few microorganisms survive. When you have a pH of 6 or 7 all the time, because you're antibiotics for months and months and months, chance exists that there is a plethora of microorganisms that are not supposed to be there and sit and colonize, will eventually take over. And again, now a chronic use of antacids has been linked to cancer. So I will be definitely skeptical to do this for way too long. There is a total revisitation, for example, the antacid use in pediatrics that has been, routinely implemented. But say that again, when it's needed, it's needed. You can't do without it. But I would not. I'm starting to be a little bit concerned about the over-the-counter antacids, so that you can go and buy your own Zantac or the PPI over-the-counter, because again, it's what we see what's going to happen here.
One more?
One more.
One more. Okay, last one. Okay.
Hi, what about the use of raw milk in helping to rebalance gut flora?
Now we need 3 hours. There's been a tremendous popularity of raw milk. And again, I've seen this, in fairs and in blog discussion and so on and so forth. The good news, indeed, is that raw milk, not pasteurized, it really is, the wealth of energy and nutrients that you give to feed the right microbiota is huge. And definitely, it's definitely much more, natural to use raw milk. The reason why we pasteurize milk is because a lot of infections that the breast gland of cows, particularly the ones that are grown in inhumane conditions, it's way too risky. We have a joke with our daughter that, you know, when we go food shopping, she pretends that, you know, the cow is grass-fed, is running around, and when went to be slaughtered, she was singing, you know, throughout, you know, the product, so she was dying happily. Otherwise, that meat is not good for her. And again, all this to say, if you will have that kind of condition, so in other words, animals grown under that circumstances, I will be less concerned about raw milk. But you know, you just visit some of these, you know, mega farms, and you realize that that would be way too risky. All right. Well, thank you very much. Appreciate it.
Thank you very much, Dr. Fasano, for coming to speak to us.